In this brief presentation, I will provide an interpretation of what is known as the mean or average value. Before we get into how to interpret the mean or average value, let's take a brief look at the formula for calculating it. The mean or the average value, which is represented symbolically by what we call x bar, that is the letter x with a small bar written above it, is calculated from a set of data values by the formula x bar equals the sum of all the data values divided by the number of data values. Now that we've taken a look at the formula for calculating the mean or average value, the question comes up, how do we interpret the mean value? Let's take a look at a brief example. I'm going to go ahead and consider that I have two data values, 30 and 60. Now I can go ahead and place those data values on a number line, and you can see that I've done so using small squares to represent those two data values. We'll call those small squares weights. If I now look at the data values and the portion of the number line between them as being like a seesaw, the question comes up, where would we place the pivot point of the seesaw so that the data values balance one another out? Now, if you know anything about seesaws and how to position pivot points for the seesaw, and if the weights are equal at either end, we know that the pivot point would be placed right in the middle of the seesaw. That is at the value 45 on the number line. Finishing up our example that we've been using with the two data values of 30 and 60, let's go back and use the formula for mean value and see if we would get the same result, namely the value 45. So the formula again is mean value equals the sum of the data values divided by the number of pieces of data. And in this case, we know the sum of the two data values is 30 plus 60, or 90, and the number of data values is 2. Plugging those into the formula, we see that indeed we get 30 plus 60, which is 90, divided by 2, giving us the value of 45 for our mean or average value. Let's look at another simple example to see if this way of interpreting the mean value by use of a seesaw actually works for a slightly more complicated case than what we just looked at. So I'm going to consider three data values, 30, 30, and 60. Again, I can place those values, representing them as small squares or weights on a number line, and I would see the following. Two small weights at the far left for two 30s, and one small weight at the far right over the number 60. Then again, the question is going to come up. Where would we place the pivot point of the seesaw so that the data values balance one another? Now, knowing a little bit about physics and the way that weights and seesaws work, we know that the pivot point in this case would need to be 1/3 of the way between 30 to 60, or in this case, the value 40 on the number line. It's worth noting at this point that if we were to apply the formula to these data values, 30, 30, and 60, and we added them together, that would be 120, and if we divided that by 3, the number of data values in this case, we would also get the value 40, thereby confirming this interpretation of the mean value. I hope this has been helpful in understanding what the mean value is. It's also worth pointing out that the mean value is also called oftentimes the weighted mean, and that's where the idea of the weights comes from, is this example I've shown using a teeter-totter as an example.